Today we are starting with the digestive system, a really important system, one which we can all identify with. Everyone here probably has a pet, and everyone's pet, unless they're like a cat and old, probably likes to eat food, right? Okay. My dog loves to eat food. So we're going to talk about the process of digestion and how we can transform nutrients into the raw materials we need to repair the body and also generate energy. Next. Okay, so digestive processes. The first of these is mechanical processing, and this has to do with prehension and mastication. I know mastication sounds like something we shouldn't talk about in an animal science class, but it just means chewing. So we're chewing up the food, breaking it down into smaller pieces so that it can be more easily digested. What is prehension? Grab onto something. So how does the animal grab a hold of its food? Now, you know, dogs didn't evolve with kibble just showing up in the primordial bowl out on the plains with the cavemen and stuff like that, right? They actually had to rip food off of an animal or something like that. So their teeth are designed for prehension. Same with cows and other ruminants, right? They're designed to rip the grass off. Okay, so the teeth are designed for that. Secretion. We secrete a lot of stuff in the digestive tract. Give me an example of some stuff we might secrete. Digestive enzymes. Pepsin, trypsin. We've got lipases, all kinds of enzymes that break things down. We also have a lot of saliva. Okay, you were talking about the fact that ruminants secrete some 30 or 40 gallons of saliva a day. Just like, you know, my dog comes close. Like if it's like pizza day or something like that, he can get pretty close. So there's a lot of secreted enzymes and acids. Then we get down to the actual technical digestion. That is taking large molecules, breaking them down into smaller molecules. So what kinds of molecules is your dog ingesting? Like what's in its food? Proteins. And what are the building blocks for proteins? Amino acids. So somehow we have to break down those large proteins into smaller amino acids so they can be assimilated. And then we have absorption. We have to get those digested nutrients, the amino acids, the monosaccharides, what have you, through the wall of the GI tract and into the bloodstream. And if they can't be broken down all the way, they can't be absorbed. For example, anyone here lactose intolerant? Yeah, so what happens to that lactose, that milk sugar? It doesn't get processed. It stays in your digestive tract and it attracts water towards it. So yeah, it can't get absorbed. Thank you. All right, elimination, of course, we need to get rid of the excess material in there, fibrous material, undigestible material, but at the same time we want to hang on to as much water as possible. This is primarily going to be the job of the large intestine. Okay, so two types of digestion, really quickly. We have mechanical digestion that has to do with chopping things up and grinding them together, and then we have chemical digestion. This has to do with enzymes, acids, okay, that are metabolically breaking things down. I like to think of the stomach and the GI tract as sort of a washing machine, right? Okay, how does your washing machine clean clothes? Soap and water. Is that all it does? Yeah, so it does this mechanical agitation, right? But it also, the soap and the water are like enzymes that are helping to break down the dirt and pull it out of the clothes. And so we need both inside the GI tract. We need motility or muscle movement, and we also need our enzymes. Okay, so there are some species variations depending on what the animal eats, right? Okay. What are the things that animals could eat? Everything. Okay, that's my dog. Okay, so what would we call an animal that eats everything? Omnivores. So dogs are omnivores, right? They're designed to eat meats, they're designed to eat plant material, carrion, what have you. Okay. On the other hand, there's some animals that are obligate carnivores. Can you name one? Cats. Cats have to eat meat. Okay. They are deficient, they cannot make the amino acid taurine, and without meat they actually become malnourished and can die. Okay. And then we have, what is the last one? We have herbivores, things that eat plant material. Okay, so horses, cows, things like this. Which one of these foods do you think has more energy and is easier to process, meat or plant material? So we have a difference. Some people say it's easier to process meat. Some people say it's easier to process plant material. Let's go to the next slide. We'll find out. So this is a representative digestive tract of a dog. And I'm going to show a dog, I'm going to show a ruminant, and then a horse, and we'll see how things change. This looks pretty much like our GI tract. Okay? Organ number 1, what do you think that is? Stomach. Okay, organ number 2 down there, what's that? Small intestine. And 4 and 5 is the large intestine. And so the stomach is where first digestion is going to happen. We're going to break down proteins using pepsin, things like that. The small intestine in omnivores and carnivores is where we absorb a lot of the nutrients. Okay, the amino acids that were broken down in the stomach are absorbed in the small intestine. And the large intestine is primarily there to absorb vitamins and also to absorb excess water. So it's a pretty simple digestive tract. And of course, their teeth are adapted to our carnivorous lifestyle, right? They have these sort of incisors that are good at ripping and tearing, and the carnasal teeth that are good at tearing as well. Now let's go look at a cow. Okay, first of all, a cow looks a little bit different. How does its teeth look different? They're flat. They have flat occlusal surfaces. The occlusal surfaces are the parts that actually grind together. And so they're doing more grinding like we do on our back molars. And when you see a cow chewing, what does it do? What does it look like when a cow is chewing? It's like this side to side. You know, I used to have a cousin that used to do that. She had this horrible overbite. No. Anyway, the point is that they're eating vegetable matter and they're having to grind that up, and it's a relatively low quality food. The number of calories, the amount of nutrients that are in grass material is very low. How often do cows have to eat? All the time. Waking hours, man, they're eating, right? Okay. It's this way with most herbivorous organisms. If you look at horses too, unless they're eating oats or some kind of processed grain that's higher in energy, they're going to be nibbling on grass all day long. Same with gorillas and things that eat leaves, and just not a whole lot of nutrients in there. So in a cow, we have these like stomachs, the 4 stomachs, that we've got the omasum, the abomasum, the reticulum, and the rumen together where fermentation happens. Because what's the main carbohydrate we have in grass that most of us can't digest? Cellulose. Okay. Cellulose, okay, can't be digested by humans. Your dog can eat it, right, but it just passes right through his fiber. But they have this rumen full of microbes such as bacteria, but also protozoa that help break it up. So it's a really complicated apparatus, this rumen and reticulum and so forth. And of course, they have a very long small intestine and then long large intestine. Herbivores have longer guts than carnivores because they want to absorb as much of this material as possible, because it's a very low quality food, so they have to be very, very efficient. Now let's go take a look at a horse. Okay, so horse, what was number 1 again? Stomach. Number 2 is the? Number 3 is the cecum, and number 4 is the what? Where did we change? What looks very different to you? Cecum in the large intestine. Whereas ruminants, things like cows and sheep, are what we call foregut fermenters. They do all their fermenting in their stomachs. Okay? Horses are hindgut fermenters. So the fermentation with the bacteria and the protozoa go on back here in the colon and stuff like that. So it's much larger, much more well-developed back there. And this is where, again, these organisms are breaking down cellulose and extracting nutrients that are going to nurture, give nutrition to the horse. Okay, so their teeth are kind of similar to that of cows, except they do have full incisors on the top and bottom, and also molars for grinding stuff. They're designed for a herbivorous lifestyle. Okay, now let's go to another animal. This is a fish. Now hold there real quick. I want you to just look at the teeth and tell me, what do you think this animal eats?
Plants.
Why do you say plants?
Because they're flat.
Yeah, they're kind of flat. Okay, go to the next slide. All right, so yes, you are right. This is a herbivorous fish. This is Manini. He did some life history work on this. And if you cut this thing open, it's just full of green, just gooey green guts all over the place. And they're eating from sunrise to sunset, just sitting there, and these little comb-shaped teeth are just scraping off the reef, and they have to eat all the time. Whereas an eel or something that eats like other fish, they might eat once a week. You know, it's like a tiger or something. They don't eat every day because they're eating high quality food that has a lot of calories relative to the energy take to get it. Whereas a herbivore, you don't have to ambush your food. You don't have to be like, salad, and then. But you do have to eat all the time in order to make enough energy to keep up with your own caloric balance. Thank you. Okay, so that was just an overview. Now we're going to go into detail about the areas of the digestive tract. I've already shown you a little bit of what we call the GI tract, the gastrointestinal tract, which is the hollow tube that extends from the mouth all the way down to the anus, right? These are connected. How do we know these are connected? What goes in comes out. So has your dog ever eaten anything that you needed to get back? What? Somebody tell me a story. Go ahead.
Okay, so it wasn't something of mine, it was something of his.
Okay.
Or hers. So I had this dog, my grandma has her now, and she had a Grinch, so we got her for Christmas.
A Grinch?
A Grinch.
Okay.
Like a little stuffed toy.
Like you were a mean one, Mr.
Yes.
Grinch? Okay.
So she likes to chew on the toys and like rip them apart, little terrier, and she ended up eating his arm, and we were like, So one day she was outside and went to the bathroom, and literally it was like his green arm was just like.
Nice. Oh, that's a good one. I can't beat that.
Yeah. Like the whole arm. It was just like.
Right.
Covered in.
And everybody knows you don't pull on the arm as it's coming out of the thing. No, my brother had a dog that would eat like a loaf of bread in the plastic. And so then they noticed like when the plastic started coming out, but you're not supposed to pull on it, right? So they had just to wait over a period of hours while a little bit more plastic would come out, and a little bit more plastic would come out. So yeah, it is a big hollow tube. And your book makes this point that, it's not inside your body. Everything that goes to that tube is sort of outside your body. It's this weird thing to think about, but the nutrients that get absorbed have to cross that tube and make it into the bloodstream. So the tube is really for processing, and whatever we don't need stays in the tube, becomes fecal matter. Whatever we do need has to come out of the tube and enter the body. Okay, so that's our GI tract, and everything else is part of our accessory organs. Our mouth, our liver, our gallbladder, all of these are important in digestion, but they're not part of the hollow tube. Thank you. Okay, we've already talked a little bit about teeth and how tooth shape can help us figure out what an animal eats. Generally, carnivores are going to have very pointed teeth up front. Okay, their incisors are good for prehension, grabbing a hold of prey and making sure you're hanging on to them. Whereas herbivore teeth, again, they don't have to be like, grass. So they can be flat all throughout. Even the front teeth are going to be relatively flat to have these really broad occlusal surfaces that gives us more surface area for grinding up that cellulosic material. Okay. Thank you. All right. So the incisors that are up front, where are your incisors? Okay. Now they're little bitty teeth in dogs, but they're in the incisive bone, right? And then behind that we have our canine teeth. Very large teeth, again, for grabbing a hold of prey and hanging on to a live prey that doesn't necessarily want to be eaten. And behind that we have our premolars and our molars. Now the premolars and molars in carnivores and omnivores aren't as flat as they are in, let's say, a herbivore. Okay? In fact, if you look at these teeth right here, these are our carnasal teeth, which is our premolars and molars right here. These are the ones that have the largest, most developed roots here. And these roots ensure that the tooth stays embedded in the respective bones, the maxilla and the mandible, but they can also be very difficult if these teeth need to be pulled out. Has anyone in here ever had to extract a tooth or been in? So how difficult is that?
The ones with the three roots are so tough. Sometimes you have to cut them in half to pull half and then the other half.
First of all, vet techs should never pull a tooth, right? Okay. Right? But if the doctor has to pull the tooth, he does know that these are going to be some of the harder teeth to get out because they have so many roots in here. And so one of your jobs later on as a vet assistant or vet tech will be to provide dental prophylaxis. And in a dog, it's usually like, okay, we're going to clean the teeth. But in a dog that hasn't had a tooth cleaning quite a while, it might also entail pulling some very badly damaged teeth that are damaged either through fracture or they're damaged through periodontal disease or something like that. So pulling teeth is not uncommon, and it can be very difficult if it's a multi-rooted teeth like that. Thanks. Okay, now your textbook goes into the numbering system that we use for teeth. I'm not going to make you remember this system because coming up next year when you take dentistry, you'll have to remember the system. And there's actually 2 or 3 systems that we use, but I just want to explain how the system works. So we'll go up to the next one here. So this shows the total number of teeth in all these different species here. You should know, for example, the porcine, the pig is the one that we base everybody on. They have the greatest number of teeth, 44 teeth. And those teeth are divided into 4 arcades. Okay? So we have 2 upper arcades and 2 lower arcades. And so we could signify how many teeth are in each arcade and what type they are based on the numbers. So for example, I, uppercase means incisor, and 3 and 3 means 3 upper, 3 lower. Okay, C, what do you think that means? Canine, 1 upper, 1 lower. And P, 4, 4, what does that mean? Premolars. Okay, 4 on the top, 4 on the bottom, and molars, 2 on the top, 3 on the bottom. So this is the formula system. Yes?
So it said, while I was reading, it said the total number you get by adding and then multiplied by 2. Is that because only the formula is only doing half the...
It's only doing half the job, right? So it's doing 1 upper arcade, 1 lower arcade. And if you have lowercase letters, that just means these are your baby teeth, right? So, a puppy would have 3 incisors on the first, 3 on the bottom. It would have a total of how many incisors? 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And same there. So just lowercase letters indicate that it's a baby tooth, a deciduous tooth that's going to be lost. Okay, thanks. All right, now teeth themselves are pretty cool structures. They're made of the strongest substance in the body, which is what? Enamel. So enamel is covering the outside of the tooth there. And depending on whether we're talking about a herbivore or a carnivore, the enamel in a herbivore may go all the way around the bottom of the tooth, whereas in carnivores and us, the enamel only goes around the top part, the exposed part of the tooth. Okay, beneath enamel, we have dentin. Now, dentin is also calcium carbonate, but it's much more easy to break down. So if you've gotten a cavity that's gone just through your enamel, they probably want to get it filled because once the enamel is destroyed or has a hole in it, it's pretty easy for bacteria to start working away on the dentin here. It's quite a bit softer, and eventually they make it down to our pulp cavity, and that's when you're like, oh, that hurts, right? Okay. How can you tell if your dog has a dental carie or a cavity? Yeah, it stops eating if it's like, one of those dogs where it's in a lot of pain. My dog, I'm sure, would still be like, I need food, but he wouldn't necessarily stop eating. He might try eating on another side of the mouth or something like that. And so it's harder to determine with animals if they're having any tooth pain because they like to eat so much. In any case, the other structures that you need to be aware of in here are the periodontal ligament. There's connective tissue ligament that is uniting that tooth and holding it via cementum into the either the maxilla or the mandible. And it's important because during periodontal disease, bacteria and inflammation begin to work on this ligament. And what happens to the tooth? Before it rots, how else can we tell that we have periodontal disease? Gets loose, mobile, right? You get a little mobility. You ever go to the dentist and, a little mobility in the tooth is never a good thing. The other thing they'll go test is they'll go down there with a probe and see how deep the pockets are around those teeth. If the gums are inflamed, if the pockets are deep, and if the teeth are, mobile, that indicates we have a pretty advanced stage of periodontal disease. But again, this is a whole nother class, so we'll go on. All right, so things that you will learn how to do later on as a technician. Well, you'll definitely become proficient in the dental prophy. Whole semester spent doing that, where we have, usually 3 going on at the same time. You're working on cats and dogs, and these are shelter animals, and so they've probably never had a prophy before. We have to put the animals under anesthesia for this. Why do you think we have to do that?
They're not going to hold their mouth open on their own.
They don't want to hold their mouth open, right?
And they're going to bite you.
And it's for their safety and your safety. Because just like in a human, when you go get examined, there's 2 stages. There's what we call the scaling, where they take the dental probes and they're scraping stuff off, right? And then there's the polishing. Polishing is where we go polish all the scrapes out of that so we don't create a greater surface for more plaque and bacteria to grow on. There are some places in Hawaii that will do what we call a standing dental, where that animal is awake and somebody just sits there with a curette and goes down the teeth and tries to scrape them off. But actually the AVMA has come out pretty strongly against that because it can be dangerous to the dog, and it also introduces these scratches on the teeth that if they're not polished out could cause more problems in the long run.
But don't for horses, you just give them a sedative, right?
Yeah, you're not going to put a horse under for, well, first of all, you're not really going to give them a prophy in the same extent. Horses, certain parts of their teeth continue to grow, and so we don't have the same worries in there, and they have enamel, it goes all throughout their teeth. I've never worked with horses' teeth. I've never done what this woman is doing now. She's floating the teeth, and it's because sometimes they get little spikes on the cheek teeth, and they actually have to be ground down. And so, yeah, they're a different ball of wax. You don't ever just sit there and give the same sort of dental prophy you would to a horse. You might do an inspection. And you can sedate them, and they also have a gag that they can put in your mouth. I think it's a McPherson speculum that holds their mouth open. Okay. All right, so other things in the mouth. The mouth is where mastication starts, but we have lots of different types of enzymes and substances that are being secreted. First of all, we've got saliva, which is a liquid component. We've got, in the herbivore, salivary amylase. Okay. Anytime you see ASE, it indicates that this is a what? It's an enzyme that breaks something down. So a lot of enzymes end in ASE, tells you it's an enzyme. Unfortunately, there's some enzymes that don't end in ACE, but if you see ASE, well, you want to think it's an enzyme. So salivary amylase breaks down amylose, which is simply starch. Okay. So we find this in cows and things that have more of an omnivorous diet. I don't think there's much at all in dogs nor cats. Also in there we have mucin. Okay, mucin is a mucus-like protein, and it's important because it lubricates the food as it's being chewed up, and it also helps it to be bound up into a bolus, right? A bolus is just a ball. Think about what happens when you feed a baby something and they spit it back up at you. It's like this glob of stuffing, right? So the mucin helps to hold that food together so it can be more easily swallowed. And we do have a little bit of lingual lipase. Lingual here means what? Tongue. And what would a lipase do? Break down some fat. Okay. The lingual lipase isn't very effective, and so, you know, the major, I'd say that the major enzyme that we have in some organisms would be just the salivary amylase. Now realize that enzymes, what are they made of? What kind of molecule is an enzyme? Okay, it's a protein. And proteins work well at certain pHs, but not others. What do you think the pH is inside of your dog's mouth? I mean, just take a guess, knowing that 7 is sort of neutral, and 1 is super acidic, and 14 is super basic. What would you say?
6.
Okay, 6. You'd probably be right. 5 or 6 is probably what the pH is. Okay, it's pretty close to neutral. Okay, what do you think the pH is going to be in the stomach? Lower or higher?
Lower.
Lower. Okay, more acidic. So the point I'm trying to make is that a lot of times the enzyme that was working here in your mouth stops working when you get to the stomach. So at that point we'll have to make a new enzyme. Okay, go ahead. All right, the tongue is there for a couple reasons. First of all, it's skeletal muscle, so it's voluntary, right, when your dog comes up and licks you to death. It's there to manipulate food so it can be swallowed. It's also somewhat important in phonation, but because dogs are not, up there enunciating, the rain in Spain happens mainly in the plains, they don't need their tongue as much for vocalization like we do. But it is there to manipulate the food. And then the cool thing about, if you've ever been licked by a cat, What does that feel like? Scratchy. If you look on their tongue, they've got what we call villiform or filiform papilla that are pointing backwards. And so when they lick you, it scratches. It's like sandpaper. And that's there for two reasons. One, for grooming, to help groom themselves and pull loose hair out. But it's also because they're carnivores, right? And even if, let's say, they weren't able to kill an animal, if they found an animal that had been killed by something else and there's still a little bit of meat on the bone, they can lick those little tendrils of connective tissue and meat off the bone using these filiform papilla. And so that's why cats have that scratchy tongue, because of these cornified papilla, that almost like teeth that are on the tongue. Kind of weird. Okay, go ahead. All right, now let's look at the GI tract itself. So the GI tract is everything, including the esophagus, the stomach, the small intestine, the large intestine, the rectum, and the anus. All of these are part of the GI tract. And there's different layers. What do we call the hollow part right here inside the GI tract? The lumen. Okay, and the lumen is lined with epithelial tissue. And the epithelial tissue here is called mucosa, okay, because it's made up of epithelium for one, a cell layer there, something called the lamina propria, and then the muscularis mucosae. And so it's important for a couple of different reasons. One, it's important for secretion. Okay? What kinds of things are we secreting in our GI tract? Enzymes, okay. Acids. Okay. The other thing is absorption. Okay. Where does absorption take place in your GI tract? Where's the small intestine? Okay. So once the nutrients are broken down into the monomers, they can be absorbed in the small intestine. In the small intestine, you think we'll have a simple epithelium or a stratified? Simple. Simple's better. Why? More absorption. What about in areas like the esophagus? Stratified, right? Because we're not absorbing in there. And you just think about, again, when your dog gets a hold of something, he knows he's not supposed to eat, and he sees you coming, he's going to do a minimum of chewing, right? He just, just sort of like a python getting around something. And so the esophagus has to be a little bit more sturdy and less susceptible to tearing, because it's going to have food that's not completely digested passing through it. So it's probably going to be a stratified epithelium. Okay. The other function of the mucosal layer is reduce friction, right? We have mucus secreted to reduce the friction, to help us get things through the GI tract. And most importantly, it's there to protect the underlying layers from digestion. Click one more box. So you may not know this, but the mucosal epithelial cells have a very short lifespan of around 5 to 7 days. And so they're continuously being replaced. Why do you think they have such a short lifespan?
Well, they get damaged
They get damaged by what?
by whatever's going through.
The food, but also the chemicals. Think about the enzymes.
Yeah.
Proteases digest proteins. What do you think these cells are made of? Acids help to break down proteins and denature it. These are made of proteins. And so it's this very acidic environment. It's a very hostile environment. And so in order not to get an ulcer, these cells have to regenerate at an amazing rate every 5 to 7 days. Okay? And that's why when we look in poop, you can see that it's mainly made up of, there's bacteria, but a lot of epithelial cells too. So don't ever poop at a crime scene, because we've got your DNA, all right? It's in there in your cells. All right, the next layer below that is called the submucosal layer. It's dense areolar connective tissue. There's a lot of blood vessels in there, a lot of lymphatic vessels. This is all the plumbing that's going to carry the nutrients away from the mucosal layer as they're absorbed. Okay, so blood and lymphatic vessels. It also helps to regulate the movements of the mucosa. There is a lot of nervous tissue in the gut, right? People say, think with your gut. Well, there's no conscious thought there, but there are more nerve cells in the GI tract than in the spinal cord. So there's a lot of sort of automatic control going on there. Okay? All right, so we had our mucosal layer, our submucosal. Now we have our muscularis layer. And this is made up of muscle tissue. Okay? And it's usually several different layers, some that's circular, some that's longitudinal. And so the muscularis layer is there to help propel things through the digestive tract. And it's also there to help us mix the contents of our stomach with all the different secretions in there. So it can sometimes be skeletal muscle, and most of the times it's going to be smooth muscle. I want you to think about eating food. And when's the last voluntary movement you make in deciding to eat and swallow your food? Swallowing, right? Because once you swallow it, like, it's all smooth muscle after there. And what's the next voluntary point? Defecation, right? Everything else is smooth muscle. And so that's where you have a picky kid or a picky dog. They don't want to eat that pill, right? You just, oh, I don't want to eat it. If you get it past their skeletal muscle, get it into their esophagus and their pharynx and back there and get them to swallow it, you start a reflex that they can't control. Okay, so it all involves smooth muscle for the, except for the actual chewing. Okay? All right. All right, and the last layer here is called serosa, which is a serous membrane of areolar connective tissue. And this is important because, look, it has blood vessels and nerves going through it. So its major functions are to secure the digestive tract to the body wall and also protect the other 3 layers. You know when you see those like slasher movies or somebody like that, and somebody gets their abdomen cut open and you hear that like, as their like guts fall out on the floor and the guy is sitting to pull his guts back in? That doesn't really happen because this serosal layer is united with the body wall. It's confluent. It's attached to it. And so yeah, if you got your abdomen cut open, your intestines would hang down a little bit, but it wouldn't be that unseemly where you were having to pull them off the floor because of this layer. Okay, next. All right, now swallowing, again, is the last voluntary thing we do before defecation. And remember, it involves the pharynx. And the pharynx is important. Why? Yeah, it decides what goes into which tube. What are the 2 tubes we were talking about? Trachea and esophagus. Which one's up front? Trachea. Okay, so here you've got your trachea, you've got your esophagus. Okay, if you have air coming in, your epiglottis will be up. That air can pass down your larynx and into your pharynx. On the back here, this is your esophagus, and you can see you have a sphincter in there that's holding that esophagus closed. Okay, now let's take a look at what happens when you swallow something. So you've just eaten something green and gooey, and it's passing past your larynx, and your epiglottis closes over your glottis that diverts the food into your esophagus, and that esophageal sphincter will relax. Now, what is a sphincter? It's a ring of muscular tissue around the hollow tube that is our digestive tract. And most of the sphincters we're going to have are going to be smooth muscle sphincters. They open up automatically. We only have a few skeletal muscle sphincters, and the one is the external anal sphincter in the anus. That's the one we can voluntarily control, but everything else is pretty much involuntary. All right. Okay. Why do you think we would need a sphincter here and we have another one around the stomach? Well, if we didn't have a sphincter and you picked up your kid on the playground, you're like turned them upside down, and just be like, their food would come right out. That actually happens sometimes with sharks and stuff like that. But sphincters are good because they keep food going in one direction. The other thing is if they're working properly, they're keeping acid from refluxing up into the more delicate areas. So Natalie, you said you have a dog that has acid reflux. And so its sphincters aren't closed up as much, and so a little bit of that stomach acid is coming up and the pharynx and the esophagus and probably eroding the esophageal lining. Okay. Fun. Okay. All right, so once that food passes across that sphincter, it's going to enter the esophagus. And again, it's all smooth muscle in here. And the way that the food moves is through something called peristalsis. We have muscular contraction in back of it and muscular relaxation in front of it. And so that food is automatically propelled from the pharynx down the esophagus into the stomach. And most of the time, you're usually not conscious of this except when you swallow something that hurts, right? Have you ever taken that when you swallow it and you're like, oh my God, it's taken forever, and then sometimes something will get stuck over here or something like that. But in general, we're talking about 5 or 6 seconds it takes to make it from the pharynx to the stomach. And so we have another ring of smooth muscle down here that will limit stomach acid from entering the esophagus. Okay? All right, so the stomach. The stomach is important for a few different reasons. One is it's a food reservoir. Okay? Particularly for animals that are either eating all the time or that are eating opportunistically, it's important to have a storage spot for food, right? Think about what your dog would be eating if he wasn't getting his 2 bowls of kibble a day.
Everything else.
Everything else. He might not eat for a while, and then he's going to come across like a wounded chicken. And he's going to eat that whole thing right there. And so he needs to have a big, they can't carry around like a little doggy bag with it. So they're going to eat everything they can and have this tremendous organ for storage. The stomach has this whole area back here. The fundus is all for storage. The other thing it's important for is secretion and digestion. The stomach is the first place where we really have a significant amount of digestion. We have acid being secreted that will help to denature proteins. We have pepsin, which will help to break down proteins. But we also have a lot of mucus, and the mucus is there to protect our mucosal layer because there's not really any absorption going on in the stomach. Okay? The stomach is primarily geared for digestion. Now, there are some exceptions. There's some drugs that can be absorbed in the stomach. Certainly alcohol, a little bit can be absorbed in the stomach. But for the most part, most absorption should be happening in the intestines. And we're not talking about ruminants at this point because ruminants are weird. All right. The other function of the stomach is mixing. Okay, so we've got mixing of the various substances, the acids, the enzymes, and the slurry of food. We have to mix those together, just like, I have one of those high efficiency washing machines. Now, a regular washing machine's spinning all the time, right? How does a high efficiency washing machine work? You ever seen those? It'll spin and go lump, lump, and it'll just stay there for about 5 minutes, then it'll go lump, lump, and spin around again, and somehow it makes clothes clean. I don't know how it works. Stomach's the same way, right? It's not continuously contracting, but every few seconds there'll be a wort, 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 and it will mix the food with the enzymes in there, give them time to break things down, and then mix them again. Okay. And the last thing is the stomach regulates the delivery of what we call chyme into the small intestine. Chyme is just that slurry of digested food matter and enzymes and mucus and all that stuff. And it's important because the small intestine, at least in carnivores and omnivores, its primary goal is what? Absorption. Still important for digestion, but it's also really important for absorption. And unlike the stomach, it can't act as a reservoir. It can only deal with a certain amount of food at one time. And so the stomach's job is to make sure that only a little bit of this chyme goes into the intestine with each contraction. So this area right here is the pylorus or the pyloric sphincter. And it's got a very, very narrow opening. I like to think of it as like a Tabasco sauce bottle. Everyone knows what those look like? Yeah. Like no matter how hard you shake that, you're like, it's like, wheek, right? Every time you shake it, just a little bit comes past there. It's got this really narrow orifice, and it's the same thing with the pyloric sphincter. So that just allows a little bit of pre-digested food stuff to enter the small intestine with each contraction of the stomach. It prevents the intestine from becoming overloaded. Thanks. Okay, so we'll start out looking at the monogastric stomach. So mono here means one, and gastric just means stomach. Okay, so we're talking about humans and cats and dogs, and to some extent horses, although they're weird when we get into the lower GI tract. But the areas we have here are the fundus, the body, and the pylorus. The fundus is the least reactive area. There's the least amount of muscular contractions. Food is pretty much stored here in the fundus. Okay? The body is more muscular, and there's more gastric pits in there and more enzyme secretion. And so as food moves from the fundus to the body, it is going to be digested a little bit more quickly. And again, the pylorus is that narrow orifice, the junction between the stomach and the intestine. And so that's going to be what regulates the amount of food that makes it into the small intestine. Now, while I'm on the slide, I just want to point out a couple of curves here. We call this part right here the greater curvature. So go ahead and label that, because it's the outside curve, the greater curvature. And the part in here is the lesser curvature. Now, what organ is directly above the stomach or cranial to the stomach? No? Liver. In fact, the liver pretty much covers up the whole stomach. When you get into your cat, you're going to be like, cat's got no stomach. Okay? Can't find it. So the stomach's being covered up by the liver. And what is covering up, or what's directly on top of the liver? Diaphragm. So draw yourself just in there, diaphragm, liver, because, you know, we don't see those right here, but it's important to realize that you have to search for the stomach. You have to search for the GI tract when you get into your cat. Okay. All right, the other thing, I mentioned the greater omentum earlier in a previous lecture, and this is a picture of it right here. This is the greater omentum of a cat. Up here you can see the liver, and around here is the greater curvature of the stomach. So the greater omentum hangs off the greater curvature. And we're not really sure what the function of the greater omentum is. It is certainly a spot that stores fat, particularly in humans and males. So we have a lot of abdominal fat, so energy storage. Some people think it might be important for protecting the intestines, helping to repair many tears or adhesions in the intestines, but really that's just all conjecture. I'm not, we're not absolutely sure what the greater omentum's for. Okay. No, mechanical digestion in the stomach. Remember, we have some mixing waves that happen at various time intervals, somewhere 15 to 25 seconds. More frequently if you or your dog is aroused and really hungry. Okay. The least intense, again, are going to be in the fundus, which is important for food storage, and more intense in the body. And with each contraction, a small amount of that pre-digested food material passes across our pylorus. Thanks. Okay, so what kinds of cells do we have in here? We have lots of exocrine cells, or exocrine glands. And what was the difference between exocrine and endocrine? Exocrine cells or exocrine glands have a duct that carries their secretions to a body surface, whereas endocrines do not have a duct. Their secretions just diffuse through tissue until they make it into the bloodstream. So these exocrine glands secrete things like mucus, okay, which is important for lubrication. It's also important for protection, because this mucus is usually going to be pretty alkaline. Why would we want our mucus to be alkaline or basic?
So the acid doesn't eat through the tissue.
Yeah, to help counteract the acid so it doesn't eat through the tissue. We have our parietal cells, which secrete something called intrinsic factor and are also our hydrochloric acid. Our chief cells, which make pepsinogen, which is an inactive form of pepsin. And pepsin is just a protein digesting enzyme. And our G cells, which produce a hormone-like substance called gastrin. And gastrin helps to regulate how long it takes things to make it through the digestive tract. Okay, so just to back up and go through these divisions of the nervous system, the autonomic nervous system. First of all, somatic nervous system was what can be controlled voluntarily. So think about all the nerves that control your dog's skeletal muscles. Those are somatic. But autonomic are nerves that control things that are involuntary, like heart rate, respiration rate to some extent. And so some people even classify the cells that occur within the digestive tract as their own division or enteric. But we're just going to concentrate on here is that the autonomic nervous system. Again, two different subdivisions, parasympathetic and sympathetic. The parasympathetic one is going to be the one that accentuates or speeds up digestion, where sympathetic slows it down, shuts it down. Can somebody give me an example of why being nervous or exercising a lot doesn't go along well with digestion? What does your mother always tell you after eating you could not do? You have to wait half an hour before you go swimming, right? Which, is true if you're going to do like a really vigorous swim, but you can probably jump in the water, it's fine. But there is a little bit of truth to that, right? That you don't want to cramp, because you're doing all of a sudden a rigorous physical activity. Okay, now let's talk about the phases of digestion. We're going to start out with something called the cephalic phase. Cephalic just means what? The head. So this is a phase of digestion that begins even before food enters the mouth. Okay. This dog is looking at its bowl of food, and what is it thinking? Yum. And what is it doing? Drooling. Okay, it's doing that. And so it's drooling, right? We all know about Pavlov's dog. That's an autonomic response. It knows when the food comes out or when the bell rings, it's going to get the food, and so it's getting ready. It's just like, that food's coming, man, you know, getting ready. And I used to be the same way. Somebody would come into class, and like my one kryptonite as far as like fast food was like curry katsu or something like that. Someone would bring it from L&L, and they're sitting in the class the whole time, and I'm just like, you know. Anyway, so think about your favorite food and what it's like when you're smelling it and stuff like that. Your body's getting ready for your stomach. It's like, ooh, you know, that kind of thing. And that's because of gastrin. Gastrin is stimulating the secretion of hydrochloric acid. This is a hormone. And this visual stimulation from your brain, from your nose, sending impulses to your stomach, increasing gastric secretions and gastric motility. So the cephalic phase is getting us ready for the food that's coming. Okay. All right, now let's go to the gastric phase. Gastric here means stomach. Okay, so this happens when food enters the stomach. So let's take a look at step one. Food entering the stomach causes the pH to rise. The normal stomach pH is around 2. Now, unless you're eating super acidic food, whatever we add to the stomach is going to make the pH go up. Okay, and before the stomach can get rid of that food, it wants to bring the pH back down and make sure it's adequately digested. So the next step will be our pH receptors and stretch receptors, which will signal our nervous system, and impulses from our autonomic nervous system will stimulate gastrin and acetylcholine production, and this will cause increased peristalsis, mixing, increased acid secretion, and increased mucus secretion. So as more acid is added, we're going to get closer to that set point pH of 2 or 3, and that peristalsis will cause increased emptying and decreased stomach volume. So the stomach does have stretch receptors that are monitoring how full it is, right? Okay. Your dog and your horse pretty much ignore them, right? Okay. How many animals can, you know, stop eating when they're not hungry anymore? I mean, maybe cats. I don't know. I know some cats that are pretty picky, and some dogs. But I remember reading this one book that, you know, some relative got me, and it was about this guy. He got his first dog, and he was a really big hippie, and he's like, oh, I don't want my dog to have to only eat certain times a day. So he's just like, he put out this whole week's full of food, and just so his dog could eat when he wanted to. And what do you think the dog did? He ate it all, and he was like, and threw it up, and then ate that too. So dogs, you know, have evolved in this case where the food is not always super abundant. So you better take advantage of it, because if it's here now, it may not be here tomorrow. And so, you know, people are kind of that way too. You know, we tend to overeat. Anyways, okay, impulses from the sympathetic nervous system tend to slow down gastric emptying, whereas parasympathetic impulses tend to speed it up. Okay. All right. So what stimulates emptying? Gastric distension. Okay, the more distended the stomach is, the faster it will empty. Some, you know, proteins will also speed up emptying, and some medications. Can you think of some things that you might take that speed up the rate of food moving through your own GI tract? Even just like caffeine, okay, alcohol can promote, and things go through a lot faster. Okay, and anything that stimulates gastrin secretion or increases parasympathetic nerve impulses is going to increase the rate of gastric emptying. So intestinal phase. Basically what happens is some of that digested food makes it into the duodenum, which is the first loop of our small intestine. Now as that happens, it's going to distend the duodenum, activate stretch receptors there, and the duodenum is going to be like, okay, we've got enough food to work on for a while, and it's going to secrete two things, CCK, or cholecystokinin, and secretin. These are going to put the brakes on gastric emptying. They're going to say, all right, that's great. We appreciate the food. Stop sending it to us for a while. We're going to work on what you just sent us. And so it's going to slow gastric emptying so that we don't overload the small intestine. And it's really important because the small intestine has this job of absorption, but it also has to do a lot of digestion as well. So it's a really important organ. Okay, now, in humans, we think being omnivores, some things move through faster than others. If you're going to run a marathon tomorrow, what do you want to eat? carbs, right? You're going to carb load. You just go on there. One, because carbs are easy to digest, and if you ate them at like 5 or 6 o'clock in the evening the night before, the waste material is going to be through your digestive tract. They're not going to be still hanging out in your GI tract. It's 5 o'clock tomorrow morning when you start your run. Now, I had a friend of mine that he ran his first marathon and didn't really know anything about marathons. He bought a new pair of shoes, I think 2 days before. He forgot to grease his nipples. I didn't know you had to do that either. And he also, like, in preparing for the race, he'd only run 6 miles. That was the longest he ran. Yeah, in one thing. He'd done it a few times, but he'd never run anything longer than that. And he ate 2 Whoppers the night before. Oh. Okay. So Whoppers are over here, right? Fats and proteins. And so they take longer to move through the GI tract. And so he was experiencing all kinds of, GI symptoms. Okay, ruminants. Now this is where I wish I could bring Dr. Kelly in and be like, tell us what is up with a ruminant stomach. My understanding of it is I got to say limited. So far we've talked about animals that had monogastric stomachs, and their stomach's whole point was mainly to digest these things so that they could be absorbed in the small intestine. Now, we don't have those enzymes as mammals that digest cellulose. And cows and other ruminants are mainly eating grass and high cellulosic material. So what's doing the digesting there? Who's doing the digesting? Okay. We've got symbiotic bacteria and symbiotic protozoa, single-celled eukaryotes, that are doing that job for us. Okay. What other kinds of organisms can digest cellulose? Some of these might not be welcome. They might be in your house. No, they might be eating your house. Termites.
That's right. Go through the
Termites eat wood, but they can't digest wood either. They've also got protozoa and bacteria that are helping to break them down. And the way that the anti-termite compounds work is they don't kill the termites, but they do kill its bacteria. And so all of a sudden it goes from having all these bacteria and protozoa that can break down cellulose to having this big stomach full of wood that it can't, and that's what kills them. Okay, so cows are weird in that they have this rumen, these 4 stomachs, only one of which is a true stomach. So anybody know what the true stomach is? No? Abomasum. Okay, so let's look at this very complicated chart here that shows all the different things coming in. So the esophagus is where food's coming in, and these guys are chewing up their cud, they're chewing up grass, things like that. Some of that's going to pass in the reticulum and the rumen, which are continuous. Okay, and in there we have this type of honeycomb glandular material there. Anyone ever eaten tripe? Yeah, okay, weird people. Okay, that's where tripe comes from. And the rumen, there's going to be this fluctuation, this just sort of back and forth of the ruminal contents mixing and mixing and mixing, because in here we have a lot of bacteria, a lot of protists, and we're going to continually, sort of barf some of that material back up in the mouth so it can be chewed again and then go back in the stomach. And the other thing that cows are doing is eructation. They are belching a lot. And what are they belching up? Gases. What gases do you think? Gastric gases. Nice way to hedge your bets. Okay. Yeah, so carbon dioxide, methane, things like that. These are being produced by fermentation of the cellulosic material that's in there. Now, so you'd think, okay, these things are breaking down cellulose into monosaccharides. These guys are going to absorb the monosaccharides. Not really. What's actually happening is as these bacteria and protists ferment, they generate something called VFAs, or volatile fatty acids. And this is primarily what's being absorbed by the ruminant in order to get its calories. Okay? And these VFAs can be converted into glucose and things like that, but we're really not absorbing the glucose or the monosaccharides from the cellulose, but we are absorbing the VFAs from the bacteria. So, if somebody asks you, what do cows eat? You can say, well, cows eat bacteria. Cows, subsist off of protists and their byproducts. So it's a really neat thing. So the order of things goes the reticulum, the rumen, the omasum, and then the abomasum. And the abomasum being what we call the true stomach. And all these other things is just being stomach compartments. Okay, and there's a picture there on the side of the cow. The left-hand side, pretty much everything in back of the last rib here is digestive tract. Has anybody ever worked with cattle before? Okay. One of the things that you're going to do if you take the large animal class with Dr. Joe or with Dr. Kelly is they learn how to examine a large animal. And here it's like a lot of it's looking for symmetry, because things can happen to large animals, the same that happen with small animals, is they can get bloat, okay, where the digestive tract becomes bloated with gas. And you'll see this huge lump on the left side where the rumen is distended on there. And there's various ways of treating it. You can put a tube down the stomach and put in some mineral oil and stuff like that. Sometimes they'll actually take a trocar and puncture the rumen and just drain the extra gas that way, which just seems really weird. But they've been doing that for hundreds of years, and it saves a life in some circumstances. Okay, go ahead. All right, now in dogs, the situation we have is called gastric dilation and volvulus, also called bloat, but it's much more serious. It's more difficult to treat. Okay. And so what happens here is that the predisposing factors are large breed barrel-chested dogs and dogs that have eaten a large meal either immediately before or after exercising. Those tend to be predisposing factors as well. But if they do catch it, you'll see a dog with a large distended abdomen. You do an x-ray, everything black in here is gas. So it's just really well distended. You can't really miss it. And it's a problem because as this GI tract fills up with gas, it twists itself shut. And it's putting pressure on other organs. It's putting pressure on blood vessels. And basically, it can divert the blood flow from other areas of the body and cause those areas to become ischemic and to start to die. And so the treatment is, once they identify that, is to drain that gas as much as possible. Sometimes they can pass a tube down the esophagus and try to rotate. Sometimes they have to go in surgically. And sometimes they can put a trocar or something in there. But usually once it's happened once in one animal, it can happen again. So the other surgery that they'll consider in this case is something called a gastropexy, if I'm spelling that correct, where they're just going to tack part of the stomach to the inside of the abdominal wall so it doesn't do that rotation thing, and we don't end up having it happen again. So you saw the movie Marley and Me? You know, Marley, he had GDV, which is not uncommon for a dog of that size and that breed. So there are people I know that had an Irish wolfhound that we're bringing in the clinic, and she lost one to GDV. And so they tried to feed food that was elevated and also make sure that it didn't eat too much at one time to reduce the chances of GDV. Yeah.